Hello everyone, welcome to my channel. Today we are going to talk about WebAssembly versus JavaScript. WebAssembly is a new language which is much safer, portable and faster compared to JavaScript, and it also can be used in the backend and front end, also and run in the browser as well. Before we talk about what is WebAssembly, let's recap a little bit about assembly code for different devices. So we have a usage scenario. We have the different platforms, right? So we have a user one. We have the one C or C+ code. We want to compile it to different assembly code for code set for different ARM or Intel or AMD. Even one brand, for instance ARM, they have different ARM series. They use different assembling code, so that when we write C++ code, we have to compile and set the target device, and then we can run it on different ARM devices. And then from the assembly code, it can run into further compiled to binary executable code. We already familiar with this extension code file with the exe on Windows OS. I think most of us we used to double click this on to install something on the Windows. That is the binary executable code, and is compiled directly from this assembly code. So that's the assembly code. And if you open up the data sheet of these devices, they can give you the assembly code set. But of course, most of us we don't read this data sheet, because nowadays we program mostly in C++ and other high level languages. The compiler can do the quite good job to translate our C++ to assembly code for us. So we don't have to handwrite assembly code ourselves most of the case, unless you are talking for the high performance, because there's a trade-off between the efficiency when we use the compiler. So if you know the architecture very well, and you know this assembly code very well, you can write efficient assembly codes much more efficient. Maybe it's 30% or 50% efficient, more efficient than this C compiler that translated assembly code. But now, for most of the case, the compiler can do quite a good job, so we are not worrying about the efficiency in the performance, because the hardware can run much better than the previous generation. So they can overcome this shortness. Okay, that's the story of assembly code and why we don't use the assembly code most of the time. Yeah. And now let's introduce WebAssembly. My question is, can we create a virtual processor like ARM and CPU sitting on top of OS with a uniform assembly instruction? You see, they have an instruction for this ARM, for Intel, for AMD, for many different devices. Can we just, for these physical devices, we have the different OS, and can we create such a processor sitting on, which is like a virtual engine that they execute this program. They execute this program like a processor, but a simplified processor. But that the assembly code is unified, is uniform. So it's like an industrial standard. So everyone uses assembly code, and this processor is sitting on top of the operation system. So I guess this is the idea why they create WebAssembly, to abstract away this hardware and work environment, so that we no longer have to worry about the environments. As long as we have this virtual machine and interpret this virtual machine as a virtual processor, and then the processor using this uniform web assembly code. And the problem now first is that we provided such a compiler for different languages, and then they both come to this. We can compile all these different languages into the same as web assembly code, but code, and then this virtual processor can recognize it. And the benefit of this is that our code, once our develop our project, our code can run virtual anywhere, as long as you have such a virtual processor installed on the OS, like on the cloud or on the embedded devices, and on your desktop. You can run it anywhere. And also, this is a well isolated sandbox, so the security is well maintained. So you can install as many sandbox as possible, and it's a lightweight sandbox. So every process is kind of isolated from each other, unless you give them grant them specific access priority. Otherwise, they cannot access these local devices. For the dangerous programs, we want to purely running inside this sandbox without accessing any security issue. The devices, like a monitor, like the web camera, or something other file system. So they are well isolated. So this security has been guaranteed. Okay, so that's a web assembly. I hope you have the idea what the idea from assembling to this web assembly. From the physical devices to this virtual devices. So, and this virtual device is actually sitting on this physical device. It's just abstraction. It's another level extraction, so that we no longer have to worry about the environment and the hardware. And for one thing, we isolated it, and isolation means good security. And second is a deployment efficiency. It can work because we can run anywhere, and also because you also, if you have a piece of service, I want people to run this piece of code for me, you can give it to anybody with this virtual processor. They can run this code for you and return the result to you. Return the result for you. So that it's kind of that your program can run distributed from others, and then come together. So this WebAssembly gives a lot of more opportunity we've never seen before, and also in a lot of new new ideas, the distributed compute ideas, that formally that C++ and Go cannot do, because these two languages are environment dependent. You have to, especially when you compile the C++, you have to, you can only run on your local environment. If you want to port this your local project written in C++, you have to tell them what the dependencies you are using. So, and if you guys have compiled OpenCV on your local machine, the headache. There's a lot of dependencies, like file. You have to set up the environment. Setting up an environment is very tedious already. So that so if you want others to run the C++ code for you, no way, because not to mention the security, but the deployment environment is a headache sometimes. So with this idea of this instruction, now that everyone compiled your code into this same uniform WebAssembly code, then everyone can run it. That's a That's a genius idea, I think. This. So, and this is a Docker creator to comment on this WebAssembly and WebAssembly virtual machine, WebAssembly virtual machine. And I don't know the web abstraction for this code, but his idea is that if it exists in 2000, is it technology exists in 2008. He invented this Docker in 2008. Yeah, he wouldn't have to create a Docker. So this he's highly praised this technology, this genius idea that but this Docker and this WebAssembly virtual machines are two different approaches to virtualize the to virtualize things. Docker is more oriented at the environment, so they are simulating, okay, you want to run this environment. Okay, you pack this whole environment in a container, then you handle this environment to everyone who want to run this. But the WebAssembly is that, okay, I simulate this. Anyway, you just want to run this code. How about I simulate this environment into a processor. Everyone simulate the environment into a processor, and you just pass me the code. You don't have to pass me the environment, right? So that's the two idea, right? I hope you understand. The Docker just pack this environment into a container. So then they handed this environment to everyone, containing the code inside. And WebAssembly is that I just pass you this assembly code, and everyone, you don't have to, and without handling your environment, because we're already using the same environment, because we agree on this industrial standard. It's like WebAssembly is like a web industrial standard, so the industry use the same assembly code for this virtual processor. I hope you get it. So that's a difference of this technology. Also, but now the WebAssembly, you don't have to write assembly code yourself. Just like we don't use assembly code, we don't write assembly code for the actual ARM nowadays most of the time, because we can the compiler can do this job for us. If you study the WebAssembly, they abstract this processor into a very simple way. Just just stack it to similar that. Maybe you guys, some of you guys don't know but there was a auxiliary register that to temporarily store these instructions. So they use the stack to replace the R in the assembly language. Okay, to not talk about this. It's not just a temporarily store this, or not talk about this at all. Yes, I want to say it's they abstract the hardware a very simple way and just stack it. Okay, so so even if you want to write the WebAssembly code, yeah, you can write it, because just according to the standard, it's very similar to write the assembly code, real assembly code, but far more easy. Okay, but even that, you don't have to write that WebAssembly code. You can compile it from the other static language, because nowadays you have a lot of all projects were already written in C++ or C, and now you can convert this C++ and C project into this WebAssembly code and run in the browser. So now a lot of projects can do this now. For instance, the most famous one is the Google Map. Everyone use Google Map, right? So previously the Google Map can only Google Map can only run on a DAX environment. Now with this with related in the where is it? Sorry. But so now with this rewritten in WebAssembly. Now they can run in the browser. The other one is a Figma. Figma is famous for front-end development, right? So now you also can run Figma in the browser. Also, the other one is Shopify. Shopify is e-commerce. Is an e-commerce platform, but they use the WebAssembly in the back end, not in front end, because they are allowing the customer to write their customized service code in the back end without threatening their system security, because of the sandbox, isolation. So that and previously, if the customers write something in the JavaScript, the provider, maybe the service provider, may worry about this security, because the JavaScript is a dynamic language. They can access a lot of local devices, like a file system, like something like that. So they were sent, if this customer service code is not isolated well, they can jeopardize this whole system. Okay, so that's it. And now let's recap a little bit about the JavaScript. We know JavaScript they can now run in the Node.js virtual machine engine, same as the A88 running in the Google Chrome browser. So it's same kind of isolation idea. That's our JavaScript language is that I write this project, I can run it anywhere. But this is a JavaScript, virtual engine, virtual machine. So yeah, this JavaScript is not that well designed, and because of security problems, and this virtual machine is not targeted for the sandbox isolation. It's not targeted for that. So they have a lot of there's a lot of issues. If you give me a piece of JavaScript, you want me to run it, I would do, oh no, hell no, I don't want, because I don't know what's inside your JavaScript code, right? How they can access, what kind of device they want they can access. So that's a security issues. Even though you can run anywhere, I can build this environment for you, and you can run my code on it. I know, because I don't want it, because it is security issues. So the way this JavaScript run is that they first have to parse and compile the JavaScript into the bytecode and then run it. So you see the compared to the WebAssembly, is that WebAssembly is static code. It's already in the bytecode, and so they don't have to parse it and compile it. If you analyze, debug the JavaScript, how it runs, you will see that this time frames is quite longer than this running time frame. So that's why JavaScript is not so efficient, because they have to take a longer time to parse and compile. But now suppose this both JavaScript and WebAssembly can run in front end and back end. I give it as this browser. Now they can have a JavaScript engine, also have WebAssembly engine, and here I illustrate how this browser runs both JavaScript and WebAssembly. So in HTML script tab, you see you can load this WebAssembly code and run it in the sandbox, isolated sandbox, and then return the result to this. So it's isolated. It's running in an isolated sandbox. Compared to JavaScript, it's have to parse it and run. It's not running in the isolated, because it's running in a V8 virtual engine. Sorry, which engine inside this browser, and then return the result back to this. So because the assembly is the bytecode, so it can run much faster than the JavaScript, and also it's isolated in the sandbox, so it's access to the file system and other devices is restricted, so it's much safer compared to JavaScript. I have mentioned that before, right? So what you can do with the JavaScript can be accomplished with a WebAssembly as well. So and WebAssembly can do more than we just talk here. And now we're going to discuss this more in the possibility that WebAssembly give us. There are two important requirements in distributed cloud computing world. First one is the deployment. Once I have to finish my project and I have to, like using language like a Go and C++, I have configured it. How can I deploy it to anywhere? Not to without repeated and complicated work to to make it run. The second is a piece of code. I have a piece of code. Can anyone run it for me without worrying about safety? The usage scenario is that there's a data center, the computing data center. They have very high requirements from the customer, from the client. They want heavily compute same code. Have to compute same code for more this algorithm, and they cannot handle the server processor can handle it in real time. So now if you expand the server to rent more server, you don't it means the money. High performance server is quite expensive, especially when you have a GPU and FPGA running inside. So the idea is that can I distribute this requirement from a custom to other individual or other distributed servers, like a home server. Okay, we can talk about this later. Yeah, so that any individual can take part in this, can get money from this data center, because you are happy to compute this result, and you give me money. So that's one way we can earn the money with our home server. Okay, so for the first requirement, people have come up with the Docker technology, right? So we're already now using the Docker. I have already mentioned that Docker use the technology that they simulate the environment. They pack the whole environment in a container, right? So everything inside this container, and I handle it to you. So that's how we handle this deployments so far with Docker. So that's a Docker, how the Docker. But now we have the lightweight assembly virtual machine, because we simulate the processor, right? I repeat again. I hope you understand it, right? So nowadays we don't have to pack the environment. We just handle it to you. My bytecode, very very small lines of bytecodes. So can you deploy it? Sure, because I already have these environments and as a processor. So I just take your piece of code. That's very lightweight compared to Docker, right? Okay, so these are two different technology, right? So it's easy to understand for the first one, and it's kind of a revolution for deployments, right? And especially people with already know how to deploy your backend server in Docker. If you heard this, I think that you are oh wow, you opened another way with not just deployment. Now we're talking about a microservice. The second one is microservice. So this opens a second opportunity, microservice. What is microservice? Means that I have a piece of code. Can anyone compute for me? It means that can anyone offload my work? I have business. I have money. Money business coming in, customer coming in, but I don't don't have enough computation. Can anyone help me to compute it? So that then I can send this service to other distributed server. And also, as a customer, you also sometimes I have the piece of computation. Can I offload? Can I submit my piece of code to this cloud server, and can you compute this for me, and can um, can you return the result to me, just like the voice recognition. I send a piece of voice recognition to the cloud, so Google Cloud, and return the result to me. And now now I sent I upload a piece of code written in the in WebAssembly to Google Cloud, and then they compute the result back to me. That is called it's this kind of service, microservice. So that you don't have to it's not you don't have to install your own server, because they can help you to have they can on a cloud side, they can help you to complete your computation, sorry, not computation, and to get back the result. So that without you don't have to install such a monster server yourself, because the monster server you have to pay every month, quite expensive, right? So this is a working scenario, requirement scenario to help you understand. Now, with this WebAssembly, it's quite easy to accomplish it. Before that, I told that even the JavaScript is not that feasible. It's not that convenient, because JavaScript, you handle me a piece of JavaScript, I don't know what you're doing back under the hook. So I worry about this. Right? So and if you give me the C code, maybe my environment doesn't meet your requirement. If maybe, for instance, the C code contains OpenCV and some libraries, and this server doesn't have such a library installed, and that it cannot run it for you. Okay. Besides the C++, you have to compile it, so it's a different. That's a different running environment. Okay. So with this WebAssembly, this genius invention, I think these problems have been solved very perfectly. Very perfectly. What's the English? So, okay. So that's I think I hope you understand that the second requirement. Now let's come to how to make money with your idle home server, high performance computer in the area of decentralized microservice. Just like the CDN and your content delivery network to speed up the access to hosted website. So every individual now can provide this compute service to offload a data center's heavy computation task, since now we have the WebAssembly backcode, which can be safely run everywhere. So it's easy to understand, right? Because this WebAssembly code can be run anywhere. Now, since you have the super good computer at home, and data center the feed of the data center is quite high, and if I have to have such a computation service, I don't want to run too many server on the cloud. I can offload my work to any lot of individuals who want to connect to my home server, to my distributed computer server. So this is how we can connect our home server to this distributed server to earn money. Suppose I have a home server, and it's monitoring IoT devices at home, and then you have a private front end server, which is a VPS. Okay, so with a static IP, so you can access. Then they can with this processing, because for most of home server they don't have the static IP. You have to have the static IP. That's why we needed such a VPS server. It's a lightweight VPS server, just doing too much thing. Don't do too much things. Just to pass, acting as like a door, so people can know your address. And also, with your own front end devices, you can pass the traffic back forwards to you can look for your home server. Okay, we're going to talk more about the architecture later, and it's from this my another project called the Sensor Media. Now we can connect this to this server, and then this distributed data center can offload work to you, and you can result back to the result back to the, and you can return the result back to the client. So that's how this works. So with the so with the home server, besides you can provide mining service and decentralized storage service, like in the Web3, and this is actually is kind of the Web3 hardware architecture. And in the Ethereum, when people talk about Web3, they didn't tell you how the hardware looks like. It gives you a peer-to-peer Web3 without giving you a hardware. This is a hardware, and every Web3 hardware can avoid this such architecture. You need to have the static IP, to be accessed to, and okay. So with essential storage service, and also you can now provide compute service to make money from our idle server at home. Okay, so that's the architecture. I think you for more on this decentralized media, it's a decentralized peer-to-peer home-based IoT search media. It's your own website and your own garden. It can replace the current traditional social media, so you don't have to install multiple social medias. You can connect with each other with your own website, once for all, and more security. Then you don't have to submit your private data to anybody. So people didn't realize how important your privacy is, our data is. So when we now it's using the social media, every input, every click we make, every data we submit, the AI now can analyze your personality and can make your next movement and can know you very in detail. So wake up, people. We have to use our own website. Do not use this free service. It's it's actually not free. Okay, so this is our project. This is open source. I hope that everyone can use their own website. Then we can talk to each other. Like you have the blog, you can write your own blog. You have your own blog and your gallery. Okay, so yeah, so like this one. So okay, so that's the idea. It's kind of the website. You can have your own e-commerce and your video live stream video. Okay, so and oh, yeah, something wrong with this.
Our movement is about replacing a failed and corrupt political establishment with a new government.
So you can have your own voice video on demand, and like you want to run your education channel, education service, and your webs. So you can do a lot of things with it. And the good thing is about every update you make, people can know it because you connect to each other. It's just like a social media. You spend a lot of time, boring time on scrolling your social media to look into what people had to post, and that's a same idea, and as soon as you subscribe to his website, their update you will know his update notification in time. Okay, Now, I want to talk a little bit about this neural cell genetic engineering that is anti-human, stuff. It's global mind control. It's those busters plot, and it's a precise neural control. Just people can read it, and I mean, a bit of microwave can control the entire army. And it's not kidding. It's real, and so you can click on this to read on my website and to read this, to understand, to know more how this is happening. And it's a mind control, and it can our brain can give some microwave, and the device can pick up like a 5G. Not 5G. It's targeted for mind control. Actually, they have a convenient for mind control, but and then AI can with AI help, they can recover what we see, what we hear, what we're thinking. Everything they can get from because they already had decoded they not just decode the DNA, but they also already had decode our brains, how to control our brains, how to manipulate our emotion and the willingness, to manipulate people secretly. So just like this one, yeah. So you don't hear about this from the mainstream media because the big figures are mind controlled. They'll be facing lawsuits and in big trouble, even life danger if they go against the dark shadow. Mind control is far beyond just reading your brains, knowing your secrets and set because they know your secrets. I mean, they can know what you're thinking, what you're seeing, what you're so they can set up the trap for you. And now, if they want to manipulate the person, they will set up a trap for you and now use the lawsuit. So they have the evidence to make you end up in jail for 1,000 years long. That's a art of manipulation with the modern law, because everyone's me included are selfish, and most of us we are not aware of this trap. So we stop this good opportunity. Actually, that's a trap. So that's why a lot of people are being controlled, because once they get this evidence, you have to listen to them, and otherwise you will end up in jail. So to be honest, I still feel that it's a dream to realize they are so mad to inject uniform slavery control gene into our blood and our offspring's blood. So why do they need to inject this stuff, since they already can read our brains? It's because our brain have a different, individual brain have different microwave pattern, so they have to stock everyone. If they want to control the army, they don't have enough data to control everyone, right? So but they can force everyone to have the same frequency pattern by genetic engineering, just like just like the mouse, just like this mouse. I would talk about that just like this mouse. I will talk about this mouse as well later. This mouse has been genetically changed, so this mouse can be controlled by the beam of light, so that the mouse can have the sexual desire. Once give this beam of light, this mouse will have a strong sexual desire. You don't have to control this movement, but you have to control the awareness, the mind, the how to say consciousness. Okay. So they can so this kind of control is far more secret, far more far more so even you're under control, this mouse didn't realize that this is under control. It's not out of this spontaneous desire, So that's what I want to say, that why they want to inject such stuff into our body, but by those to genetically change our blood and our offspring, because once this stuff mRNA stuff goes into our blood, it's precisely target for these neuron cells. For instance, you're targeting for the neuron cells that control our brain, our heartbeat, our heart. And this neuron cell will once this into this neuron cell, they can produce such a specific proteins on the surface of the neuron cell that allows other magnetic nanoparticles into this neuron cell, so they can change its frequency pattern to make everyone have the same pattern, right? So that's how they can use this microwave to control the whole army, because they have already changed your microwave pattern. So one beam of light can make your whole army sitting like still, and just like harvest the peaches on a tree. Don't doubt about this, because you already see how this mouse can behave. So you can. Once we see this result, means it's too late, because they only can secretly carry this process, and if we see these things happening like on the mouse, means that we don't have the chance to fight back, because you don't have the chance. You already been injected with the dose, and you already transformed it. By the time you've been shined on this microwave, you won't be able to raise your hand rifle. You won't be able to have chance to fight back. So remember one thing, that this basic physics of light is electromagnetic wave. If they can control the mouse with the light, they can also control our heart and many other organs with a beam of electromagnetic wave, like a microwave, right? So so I just want to say that wake up, and this is happening, just like this mouse. So this is an interesting project for deep learning, and it's called Project Brainwave. And his talk on how gene editing AI can benefit world's poorest. So this wireless signal things. Okay, thanks for watching, and bye bye.